All right, 6.1 day 2, I guess maybe day 3, depending on how you look at it. Yesterday we talked about growth and decay as far as what the graphs looked like. Remember, one of those, it's basically would be like out of 6 points in terms of making sure you know what the asymptote is, make sure you know what the y-intercept is, and then the domain and the range. Your domain is always going to be positive or negative infinity to positive infinity. That is never going to change. Your range will be dependent on if it is above your asymptote or below your asymptote. If it's above your asymptote, then it's going to go from your asymptote to positive infinity. If it is below your asymptote, it is going to come from negative infinity and go to your asymptote. That was kind of the Cliff Notes version. If you weren't here yesterday, I think everybody was. But if you need to, you can check it out again. So the second part deals with more of the modeling, or it's essentially a word problem, of growth and decay. So one thing that you will need for this is anytime we deal with growth is we're going to take whatever we have, okay, and take it to the x power. So like whatever amount that I originally start with. Okay. What I'm going to do is I'm going to have, with growth, it's going to be like y equals a. Okay, so if this is growth, 1 minus r, all to the t power. Now, the one thing that I have to do, kind of my disclaimer, is change r to a decimal. Oh, that should be a plus since it's growth. My fault. Decay. Decay is a negative. My mistake. Whenever we talk about exponential decay, it's going to be the same value or same function, but it's going to be 1 minus r to the t power. Again, I need to change r to a decimal. So here it says the value of a car Y in thousands of dollars can be approximated by the model of Y equal to 25 times 0.85 all to the t power, where t is the number of years since the car was new. So you bought a $25,000 vehicle. You want to figure out how much you lose. Whenever you lose money on a vehicle, and whenever I say lose money, basically when you go back to trade it in or you try to sell it outright, whenever you want to try to get rid of it, okay? I have a 2004 Ford F-150 that had 22,000 miles on it whenever I bought it. I bought it in 2006. Still have this thing. Still driving. 223,000 miles. I paid like $18,000 for this truck. I can't get 2 for this thing probably. So you know what? We're driving this thing until it dies. Okay? I'm never going to get the money back, okay, that I paid for it. Okay? I know that going in. Okay? More often than not, my wife and I 2 years ago, she was in a wreck, so we had to buy a new vehicle. We got one. 2 years later, the same dealership called and said, hey, we want to buy your vehicle back. Perfect. Okay? we didn't get the same amount. We ended up getting we upgraded to a new vehicle, but we didn't. We basically just put off 2 more years of another loan. Is all we did. We basically got it to where we're still paying the same amount, but we didn't get the same amount out of our vehicle as what we paid for it. We probably got maybe about $8,000 or $10,000 less. I don't know, whatever it was. Okay, so whenever you go, that first year is going to be your initial big hit. Like with this $25,000 vehicle that's in this problem, you know, I'm going to lose so much that first year. It's exponential, so it's not one of those things that I'm going to lose the same amount every single year. Okay? So like if I lose the first year of owning a vehicle, say I lose $4,000. Every year am I going to lose $4,000? No, why not? Because at some point then I'm going to have to pay somebody else just to give them my car, right? Okay? It's always going to go back to like whatever that next year is, or whatever that new year is, that's my new value of my car. Okay? If you ever look and whenever you get into whenever you actually have to purchase your own vehicle, okay, and you look, okay, you always want to go to like NADA or like Kelley Blue Book. Okay, I know Kelley Blue Book has like, or Car Trader, stuff like that. They have advertisements and stuff like that. They'll tell you how much your car's worth, because they're using basically like a depreciation value of like what your car is worth and what it originally was worth whenever it was made. So from here it talks about the car. If this number that we're dealing with as far as my base, so this 0.85, so if whatever's inside the parenthesis, if your original value is at 100% of its value, okay, or 1. If now we're at 0.85, did we lose money or did we gain money? If 1 is your baseline, what happened? Did the number go up or did it go down? It went down, right? So because this number right here went down, it's going to be exponential decay. Next question then says identify the annual percent increase or decrease of the car's value. What percentage, if 1 is the same thing as 100? It went from 1 to 0.85. How much of a percentage did I lose? So like what is 1 minus 0.85? 0.15, right? So that would be my R value, okay, whenever I plug it in. But what is this as a percent? How do I change a decimal into a percent? 1, 2. I lose 15% of value on my car every year. So it says estimate when the value of the car is going to be about $8,000. So first off, let's figure out, okay, to kind of give us a ballpark about how long it's going to take to, like, how much am I going to lose in the first year? So T represents like the number of years. Okay, this value right here are number of years for either one. So if I'm going to have 25,000 times 0.85, what is 25 times 0.85? Because the first year is just, that's the big hit. That's whenever I'm going to lose the most money. So in year 1, if I take 25 times 0.85, my car is worth $21.25. So $21,000, $21,250. If I do it again, now you can keep doing it this way, but hopefully Okay, I would at least do it. So after 2 years, so I take 25 times 0.085, or 0.85, so, excuse me, to the second power. My car is worth about 18,000. Okay. 18,600 or $62.50, something like that. If I would actually move it out to, because it's talking about it in thousands. So the first year, about how much money did I lose? About 4,000, a little less. Okay. I'm not going to lose. Did I lose 4,000 between year 1 and year 2? No. How much did I lose then? More like 3, right? Because what's the new value? Like after year 1, I bought this car or truck or whatever for $25,000. After year 1, I go back and I try to sell it. They say, okay, we'll give you $21,000 for it. No, I'm going to wait. Go back 2 years later, they say, I will give you $18,000 for it. Okay? It's not as big of a hit then. I can continue to plug values in. When do you think, so it's one of those, it says estimate. Again, you can plug in 3, you can plug in 4, you can plug in 5, you can plug in 6. How many years do you think? Just random estimate, not trying to plug in every value. That's just, it's not a waste of time, but there's a lot of extra time that we're going to use that we don't have to. Because is it going to be $8,000 in year 3? Probably not. Is it going to be, because we only lost 3,000 from year 1 to year 2. So 3,000 even from that is about 15,000. So what do we want to look at? About how many years do you think? 9? Okay. So instead of doing 3, 4, 5, 6, 7, 8, and then 9, if we go with 25,000 times 0.85 to the 9th power. All I'm going to do is type in 25 times 0.85 to the 9th power. I'm going to get 5.7, let's just go 904. Overshot it a little bit. That's okay. I'd rather overshoot it, and did I overshoot it by that much? Not really. Now, if I overshot it and I went with 9, do I want to come all the way back to like 4? No. About how much do you, so instead of 9 years, maybe we try what? 7? Maybe we try 8? Okay? If we try 7, and maybe we come back the other way, where can we land on? 8. Okay, so it's using a little bit of common sense to figure out like what number, so I don't have to try every value. If we go with 7, and we go 0.85 to the 7th power, boom. 8.0144. So about how many years? 7 years, right? So if it asks you to estimate. Please don't write down every single one. Same way here, it says in 2000, before some of you, well, before probably any of you were ever born, the world population was about 6.09 billion people. Next 13 years, world population increased by about 1.18% each year. So it went up, okay, obviously. It says, write an exponential growth model for the population of Y in billions for T number of years after 2000. Estimate the world population in 2005. So we need to write a growth model. Okay? Why is it going to be a growth model instead of a decay model? Because what do you know about that number? It's bigger than it says that it increased. So if my growth model is still just y equal to a times 1 plus r to the t power. What's my a value? What's my starting value? 6.09. What's my r value? What's my rate? It's 1.18%, so what is it as a decimal? 0.0118. Okay. Make sure whenever we have it's given to you as a percent, we have to change to a decimal. Okay? And honestly, that's going to be the biggest mistake if anything gets made. So we're just writing this thing, we're just writing the model. We're not solving anything. Okay, not yet. Now, it does tell us for every year, in t number of years after 2000. So that's going to be key as far as how we write this. So if I write my equation, I'm going to have, why do I keep making it a? Y equals. What's going to come next? 6.09 times 1 plus, what's my rate? 0.0118. Now, here's where it's a little bit tricky. Usually it would be to the t power. But it's not like we're starting at year 0. Okay? And we're not counting to year 1, to year 2. We're starting at year 2000. So instead of it being year t, it needs to be t minus 2000. Because what's t going to be? Because it doesn't say after 5 years, it says in year 2005. Now, you can do the math from there. What's 2005 minus 2005? Okay, so as far as my model is concerned, and it really is up to you as far as this part right here, if you want to rewrite that as, if you want to rewrite this as y equals 6.09 times 1.0118 to the t minus 2000 power, that's okay. I will take either the blue one or the black one. They both mean the same thing. So either of these two would work for me. So then whenever we actually want to find what the population is going to be in 2005, heck, we can even do it in 2018 or 2019. So where's the 2005 going to go? For what value? For what variable? What's the only variable left? T, right? So all we're going to do is we're going to have y equals, we're going to go 6.09. I'm going to write it as the condensed version of 1.0118 to the 2005 minus 2000 power. Again, if you want to shortcut this and you want to go ahead and write that as 5, that's okay. Okay, if you want to go ahead and do, instead of writing it like this, and you just want to go like what's in green here, and go 1.0118 and take it to the 5th power, that's fine. Whenever you type it in, I would just take it, and just since it has a parenthesis, I'm just going to go 6.09, parenthesis, 1.0118, close the parenthesis, and then take it to the 5th power. Whenever I do them, it's 6 point. What did it say to round to? I'll round it to 2 decimal places since that's what the other one was. So 6.46 billion. So after 5 years, we didn't go up a full $500 million, but we were fairly close. We went about 4/10. So again, it says to estimate the year. So about every 5 years, it's going to go up maybe a $500 million. Okay, it went up about 4/10 in those 5 years. So estimate the year whenever the population was 7 billion. So again, you know it's going to be more than 2005. Maybe you try 2010. Maybe 2010's, maybe it's a little too much. Maybe you try 2009. Okay? It's an estimate, so don't try every value. Work smart, not hard here. Okay?